so that the people, there we go, recording in progress. Just so that the people who couldn't join us can see this. We're going to wait probably 1 or 2 minutes, let people log in before we get going. Just in terms of protocol, if there are any technical problems, you can put them in the chat. Petra and myself will be able to see then if you can't hear or see, or if there's any kind of issue. You can put questions as we go along in the Q&A box, but we'll wait until the end before we start answering them. But there's a Q&A function. Just to let you know, I've got Dr. Chikunweke with us as well. Chik will be here just in case anyone's got any questions about the degrees that we do. But otherwise, it's going to be myself and Petra. Well, it's going to be Petra who's presenting this. So just waiting for a few more people to join us. We'll give it until 1 or 2 minutes past. I know that's eating a lot into the short time that we've got, but I hope you're having a great day where you are. Oh, just in case I didn't introduce myself, my name is Kim Morgan. I'm the Communications and Outreach Coordinator at UCL Biochemical Engineering. So, yep. Fine, and yeah, so you will have received the invitation through the UCL system. So I'm hoping that everyone is registered with UCL's contact system, so that if you so you'll hear about other events. We've also got some Meet Us in the Labs coming up over the next couple of months, and Chika will actually be doing a careers webinar in January. We'll also be joined by some of our alumni in that. But if you're signed up to the UCL system, you will be kept informed about that. So now that we're 1 minute past, and it looks like everyone's had the chance to log in and we've got an audience, I'm going to hand over to Petra. I will be here in the background. Any problems, you can always let us know in the chat, but otherwise, I'm going to hand over to you, Petra.
Okay, thank you so much, Kim. Welcome everyone, welcome to UCL. My name is Petra Hanga. I am a lecturer in the Biochemical Engineering department here at UCL. And thank you for joining me in this tasted lecture on cellular agriculture as a new way to producing sustainable and ethical foods. Right, so you are probably asking yourself, what is cellular agriculture? It is a new emerging field that is looking at producing useful products from cells, and you are most likely familiar with these type of products. So it can be products from foods like meat, egg whites, milk, to materials that we can actually use to produce clothing or produce or make shoes, essentially, like silk and leather. So when we talk about cellular agriculture, we usually classify the products that we can produce using cellular agriculture into categories. You can either have cellular products. So these are the products that actually comprise of various types of cells. So the cells themselves are the product. Or you can have acellular products, which are products that are essentially produced by cells. So in this category, you would have various chemicals, or you would have things like proteins. And I will be going through some of these examples. So one example of an acellular product that you are all most likely familiar with is milk. You've probably tasted it. Milk is essentially an emulsion of fats with loads of protein in there, particularly a specific protein called casein. And then on top of that, it has other things like salts, it has other things like vitamins in there. So it's formulated essentially as that liquid that we all know and enjoy. But in terms of how it is produced traditionally through animal agriculture, well, the process in itself does have some concerns in terms of animal welfare, and particularly for the past years, where the demand for dairy products, and the same for meat, as we will talk about in the next slides, has increased so much that actually the dairy and the meat industry, in order to satisfy that growing demand, they had to undergo an intensification of their processes. So what this means is that for producing the milk to which I'm referring to specifically now, the cows are actually kept in a continuous lactating state. So they are continuously, they are inseminated in cycles to keep them in that lactating state so that essentially the milk can be harvested. And they are also pretty much most of the time immobilized in place as they are connected to these machines that harvest the milk. So the natural life expectancy of cattle is around 20 years, but actually for dairy cows, because of this lifestyle that they're undergoing, it's only 5.5 years. So you can see how this intensification of the process does affect the welfare of the animal. So this is where cellular agriculture can be quite beneficial, and there are some companies now that are emerging and they are focusing on producing milk by using cellular agriculture techniques, so using fermentation and using bioreactor vessels, which cultivators in which you grow the cells. And they're focusing specifically on producing the milk protein casein, which is found in high proportion in milk. And then it's just a matter of essentially formulating that protein in the right concentrations, right ratio with other components like fat, like vitamins and salts that I've mentioned. Another example of an acellular product is Rennet, and Rennet is a mixture of enzymes that is used for making cheese. And traditionally, Rennet used to be extracted from the fourth stomach of calves, which means that actually that particular animal had to be slaughtered in order to take its stomach and process it to isolate the compound rennet. So obviously that does have some implications, ethical implications, but since about 1990, so this is one of those products of cellular agriculture that has been produced since the 1990s. And now is actually the norm of using this method rather than the traditional one through slaughter of the animal. So by using fermentation and recombinant technology, we now have this ability of producing this mixture of enzyme, the rennet. And actually by using this technology through cell culture, the rennet that we obtain is of a higher purity than the traditional rennet, is a lot more consistent, and actually it turns out that it's a lot cheaper as well, and it doesn't come with any of the ethical implications, and it doesn't require slaughter of the animal. So what I want to talk to you about is an example of a cellular product, and you will identify that some of the issues that I've just mentioned with the acellular products and how they're obtained will also be applicable here. So when we think about traditional animal agriculture for production of meat, so we imagine these animals roaming free on the fields, enjoying the sun, the grass, etc. But actually, that's not quite the complete truth. It is true, and this situation is still available in smaller farms where the animals and their welfare is appreciated and cared for, but unfortunately not in the bigger industrial farms. And because the demand for milk, the same as for dairy products, is continuously increasing, and especially with the newly developing countries, the animal agriculture has become very intensive, which means that actually the reality is that sometimes animals are caged or they are overcrowded in very small spaces. So it's nowhere near the picture perfect that we have of them roaming the fields. And this intensification of animal agriculture has come with a lot of detrimental effects. So not only on the animal welfare and obviously some of the ethical concerns related to the techniques that are involved, but this animal overcrowding, this overcrowding of the animals has in itself determined a lot of detrimental effects. So just to give you an idea, when animals are crammed in such small spaces, it is enough for one single animal to get sick, and then the spread of the disease is absolutely, it would be absolutely devastating for the industry. So in order to overcome that, the industry has started using antibiotics that were fed to the animals. But then that in itself has led to a lot of issues in terms of the global challenge that we are now facing of antibiotic resistance and formation of superbugs. Also, because of this intensification and obviously the need to satisfy that meat demand, which means more animals are required, which means the land is not enough, so more land was required. That in itself has led to deforestation and implicit loss of biodiversity. And also, you know, it is also worth mentioning in terms of the animal welfare that because of this increase in meat demand, the industry has also looked at other methods of maximizing the meat production. And that has meant feeding the chickens, for example, various things that they weren't fed back in the 1950s when they were still enjoying the grass and still, you know, roaming free on fields. And that in itself has led to actually breeds of animals that, yes, indeed, it maximizes the amount of meat that is being produced, but actually causes severe health problems for the animals and leads to a very short lifespan for the animal. So what if we could produce all these products without harming the animal, without damaging the environment, without using all these antibiotics that we know are causing more issues, without using, well, with using less resources, less natural resources like land, water, producing less greenhouse gas emissions, and actually making foods more sustainable? Why would we not do it? So this is what essentially cellular agriculture is trying to achieve, is trying to overcome all these detrimental effects that intensified animal agriculture has, you know, has caused. Obviously, it's not perfect. Some of these things are still in the concept of developing, like cultivated meat, which you might have heard in the media under various names, from cell-based meat, clean meat, lab-grown meat. These essentially are exactly the same thing. These are products that are only in the proof of concept stage at this moment, but there will be more available on the market and hopefully more affordable for consumers in the upcoming years. So what is cultivated meat or lab-grown meat? It is genuine animal meat. It's not synthetic meat. Actually, I don't like that term at all, because this is not synthetic. We're trying to mimic something that is actually natural, but we are producing it without slaughtering the animal, from only a small biopsy from the animal to get those cells to start the process with. This meat will be produced rather than in the animal or through the animal, will be produced in a controlled environment in a bioreactor or a cultivator. So think of it like rather than producing it horizontally as traditional animal farming is now, we are producing it vertically, as you can make these bioreactors as big as necessary. So you are using a lot less land in that regard. This is genuine animal meat, so it will have exactly the same composition as animal meat. It will have exactly the same taste and the nutritional profile, but unlike animal meat, because we are producing it in a controlled manner, we will also have the ability to improve it for nutritional value. So for example, we could supplement it with additional vitamins or omega-3 oils, which we know they are very good for us, but you don't find them in meat naturally, you find them in seeds. Or if the technology will advance enough in the next couple of years, maybe even take out those bad fats altogether and only replace them with good fats. So, so far to date, there have been some world's first from various startup companies worldwide, and cultivated meat has come in various shapes, as a burger patty, as a meatball, fish cake or dumpling, etc. And also it has targeted different types of meat as well, from beef to fish and shrimp and pork and even chicken, which is the latest advancement in the field and a very big milestone of a cultivated chicken product that has obtained approval, but only in Singapore, unfortunately. So hopefully more to come in other places of the world. So, you know, you would probably ask yourself now, and I'm going to end on this. So what does this have to do with biochemical engineering? Well, it has everything to do. These type of products, and not just these ones, but also cell-based therapies, gene therapies, antibody-based therapies, all these products would not be available to the public if they wouldn't have a biochemical engineer involved in their production. Because us as biochemical engineers, this is what we do. We translate technologies from the lab scale to the industrial scale so that we can actually make these products, useful products, available to the public at large and get them to where they could have the best benefits. So I would like to end on this. I hope you have enjoyed this taster lecture on cell agriculture, and happy to take any questions now that you might have. Thank you.
That's great. Thank you, Petra. And thank you, John. We have a question. So I'm just going to, here's a really good question. I'll ask Petra. Petra, how do you make lab-grown food more appealing to the general public?
So, yeah, I think that is an excellent question. It depends what you mean by more appealing. So I think what people need to understand that is this will be meat. It's not synthetic meat. Even if it's made in the lab, it will be meat. So if it has the same taste, the same, the same goodness like meat when you buy it, would you not go for it, knowing that you're actually eating something that is guilt-free, that doesn't kill animals or treat animals in a very bad manner? I would go for it. I mean, it might not be for everyone, but then again, I think a very big misunderstanding at the moment is that people think that actually this cultured meat product, these cultured meat products will completely take over animal agriculture. Well, I don't think that's going to be the case. Not in the next 10 years, maybe not even the next 20 years, 50 years, I don't know. I have no idea how far technology will get, but we simply do not have the capacity at the moment to produce more than 10% of what the meat demand is and what the quantities of meat that are produced annually. And if you think about it, those 10% will come with a lot of benefits in itself, because that means that actually there is some pressure taken off the animal agriculture, which means that the actual meat industry will not have to start thinking about other solutions like, I don't know, genetically modifying animals to get even more meat to satisfy that demand, which we know it has happened with some breeds, and actually it ended up quite badly because those animals got to the point of being completely deformed. So that's definitely not the solution to that. But it will take off some of that pressure. You also need to bear in mind that the land that we now have available is pretty limited. I mean, if we carry out more deforestation than we already have, that will have very serious consequences. I mean, we're already starting to see some of those consequences in the environmental changes, the climate change. So yeah, so it's all about, and even the cultivated meat products, it's about giving consumers options. It's not about forcing people to eat it.
Well, actually, I'd like to turn that round to our attendees and just say, can you put your hand up if you would eat lab-grown meat? Just let us know. So just put your hand up. There we go. We've got 1, 2, so 3. Yeah, so that's 100%.
Yeah, well, me too. Obviously, I would go for it for sure. I mean, there's no doubt.
Depending on the cost, and actually,
yeah. So the cost is a very big one, actually.
And that somebody else has asked a question. So regarding cost, is it possible to produce lab-grown food in the same amount of money to be produced in a traditional way?
Yeah.
Petra,
so at the moment is not. I mean, I can tell you this. First product that has been approved, and it's actually being sold in Singapore. It's currently on an order by order basis, but for one chicken nugget, which is probably has, I don't know, 10 grams or whatever, it has 30 grams, the price is around 50 Singaporean dollars. So it's not cheap. It's quite expensive. It's still quite expensive at the moment, but there are a lot of companies, and there has been a lot of investment in the last couple of years, and they're all looking towards bringing these costs down. So I would say, and I think I can say this with quite a lot of certainty, that in the next 5 years, we will probably see the first generation of cultivated meat products on the market, which will have prices, maybe not, well, actually, no, they will be pretty similar. So maybe slightly more expensive, but they will be comparative to actual meat products. Yeah.
Great, thank you, and thank you for your responsiveness there. Okay, so thank you very much for staying behind and for answering the questions. I'm going to leave it just a moment more to see if any more questions come through. But whilst we wait for questions to come through, I'm just going to say that we've got some of our researchers are joining from the labs. There's Pedro, there's Sam, and there's James, and they're covering things like CAR T-cell therapy, which they're working on. There's laser. Sam's doing some stuff. He's laser equipment that he's generating, and they'll be joining from the lab, so you can see where they work. Which is great to see them in their natural environments. Chika will be doing a session on careers in biochemical engineering. We'll also be joined by some of the engineering careers team. We have a whole team of people in our faculty who work with placements and postgraduate careers. So we'll be doing that in January. So we hope that you'll join up to those. Do sign up to them anyway. Even if you can't make it, they'll be recorded. And if you really want to, you can post a question in advance. We'll answer it, and then you can watch it afterwards as well. But since we've not had any more questions come through, I'm going to wrap this up. A final thank you to everyone for attending, and a huge thank you to Petra for presenting. And I really hope to see you in person at some point. Thank you very much. Have a great afternoon.
Thank you, everyone. Take care. Bye.
Bye-bye.
Thank
Bye-bye.
you. Bye.